I have a great honor to introduce Dario Weiss and David Fridrih of InfoGuard, of a pen testing team, and they'll give you the insights, the good stuff about how to get into networks with cleverness, social engineering, and obviously a lot of tech competence. So please continue.
Thank you very much, Katrin. All right. So where's the here? Wonderful. Okay, so thank you everyone for coming. Thank you for the introduction. First of all, maybe just a few more words about us and our team. So Dario and I, we are part of the InfoGuard Red team. We are part of the team, the professional and ethical hacker team. So we try to protect our customers by attacking them. We do this to identify vulnerabilities which real attackers could also exploit, and the most important part for our customers, of course, is we give recommendations how they can fix those vulnerabilities to improve their security posture. We are a team of about 20 pen testers from 18 to 40 plus, from apprentice to PhD, so a good, healthy mix. Yes, so today we are going to talk about real customer projects we did. These are real attack scenarios we completed. It might get a bit technical, but I hope it won't be too much. So first of all, let's just look at a context of what we usually test. Now, we offer a wide range from web applications to IoT products, your fridge maybe, the smart fridge, over standard IoT systems, networks, and maybe even the power plant in your local neighborhood. For this, we have our own research laboratory, we develop our own tools, and we have our own dedicated infrastructure. Now, I remember when I was a kid, I chose my first password, and it was line 17. I've learned from it. It's quite bad, because we can, with our infrastructure, brute force up to 100 billion passwords per second. Just as a reference, maybe the sun is 4.5 billion years old. So yeah, although sunshine is nice, maybe you shouldn't choose summer 2025 as your password. Okay, so talking about non-mainstream ways for an initial access to a network, how can one imagine this? Now, usually when talking about hackers, people imagine this, a person sitting in a dark room, hoodie on, in front of their laptop, typing on a keyboard. But the reality is that hackers can also look like this. This is me with a high-vis on and a ladder in my hands. Now, why do I wear this? Well, some people say that with carrying a ladder, you can get in basically everywhere. So we tested that. For a customer project, the customer wanted us to breach the initial external network. We tried so first using the standard methods. So we scanned the servers, we tried to identify vulnerabilities, but we weren't able to find any noteworthy paths inside of the network or into the network. So we then tried a bit more of a non-standard way through physical social engineering. I dressed up like this, went to the headquarters of the company, and within 3 minutes, without even having to talk to anybody, I was inside of their office and found an unlocked notebook and was able to install an initial foothold onto the client. So as we can see, sometimes you need a bit more of a creative attack path to get to your goal as a penetration tester or even hacker. Similar scenario here. This picture was taken around midnight. Yes, go ahead.
Do you just walk up to the laptop and stick in a USB stick, or how do you do that?
Basically, yes. Depends on the client configuration. Sometimes USB sticks are not allowed. Then you have to download something depending on the download filter, depending on the access policies, depending on the app locker, sorry. You need to use different types of attack paths, but because the physical attack path is usually not on the radar of the companies, it's not quite restricted. Yes. So this picture was taken around midnight. Why? Well, we as hackers, we of course like to stay up during the night and work, so that's why we were there. No, it's not that. It's not that reason. This company had a production site here with an unlocked Wi-Fi. We were able to exploit, so we drove there at night with a Wi-Fi antenna, and we were able to get an initial foothold. All of this in the darkness to not raise any suspicions during the day. Yes, another interesting Wi-Fi attack path by Dario.
So at that client, we had the normal approach of doing an internal pen test where do an attack simulation. And besides that, the client asked us to also look at the guest Wi-Fi. He was a bit suspicious there. So we arrived at the client location, but unfortunately the internal process was a bit too slow and we hadn't any credentials yet. So we figured out, yeah, we have the time, why don't we start with the guest Wi-Fi then? It was a huge office complex with multiple companies in there. You could just walk in the front door and then look through the different windows. That was the window for our customer. Maybe you can see something, or I can zoom a bit. On the side was the paper hanging with the guest Wi-Fi password. So great, we don't even need to get into the office of the client itself. We can just read the password. Took a photo, went back to the hall down, sit down, and logged in. From there, we were looking around, yeah, what can we do in the network? Do we find anything? And after some scanning, we found an open share. That open share contained some usernames. We were able to enumerate those. After that, let's try some password spraying. Tried summer 2025, was it before? That didn't work that time, but the next approach was, let's try username equals password, and we guessed some credentials. I called the client, can we move forward with that? And he was, sure, let's go ahead. Use the time if you have it. So we scanned again the network, look if the domain controller was reachable, and yes, it was reachable. From there on, tried to figure out what privileges do we have on the domain, and we had the privilege to request certificates for any other user. So what we did, just request the certificate from a domain administrator and use that to authenticate against the domain controller, and with that, palm the domain within half a day without even having any credentials. So on to the next. To the next example, that client specifically asked what can happen if his device gets stolen. He was pretty certain nothing's going to pop up. We have BitLocker enabled, so the drive's encrypted. There's no way forward. We said, can we try? We really want to try that. So to understand how we attack that, you need to know how BitLocker works. For those not familiar with that, there's a trusted platform module on the device, on the circuit board, which holds the key to decrypt the disk. This gets usually loaded into the RAM before it's then used by the CPU to decrypt it. So the key is located in that TPM chip and travels across the circuit board somewhere. So if we hook up some probes on the right spot of the motherboard, we can do an attack called TPM sniffing, listen what the chip sends over the circuit board, and with that, get some lines with our small little logic analyzer. This looks something like this for someone who hasn't seen it yet. It's a device you get like for $5 at AliExpress. You can order it from China, and with that, sniff the traffic between the BitLocker, between the TPM and the RAM, and get the volume master key, the key to decrypt the disk. After that, you're free. Remove the local administrator password or remove the EDR. We did both and moved forward into the domain. So what's the conclusion on those examples? Well, physical attack vectors are often underestimated. There are a lot of open doors, and those ones aren't usually in the scope, and clients usually forget that this is a thing. Other things often underestimated are IoT devices. So maybe you have heard the talk downstairs about smart cities, where some vulnerable connected device is somewhere out in the internet. This was exactly the case with the next two examples. So we had the scenario of just a normal external pen test for a client. There was a web application running, and through the server name, server header, I figured out that this was a smart sensor. So I Googled a bit more, found out, okay, this is a smart sensor used at construction sites, tunnels, railways, critical infrastructure. The list moves on. Quite some critical stuff. But it was protected by that login screen. I moved forward, looked at the documentation, and found out that the default password is not admin. It is the serial number. Okay, serial number, it has 10 digits. Takes a while to brute force, but I don't know. If it's randomized, we don't have any chance. So I looked through the documentation further and found out that the default Wi-Fi name contains the model number plus the serial number. So does anyone have a clue what you can do with that information? So to my mind, I figured, let's look at war driving data then. I looked for the model number, and surely you can see all over Europe, as well USA and so forth, everywhere where those devices are available, and found a lot of those serial numbers and the device model name in there, a huge list. I could just try all serial numbers through, or just zoom into the client's location and figure out which of the device might be his. And sure enough, that worked. I got into the web application of the device. It has some hidden feature that wasn't the first screen, but with a little bit tinkering around, we found that screen. Maybe you have noticed the binary script uploader button. It's exactly what you think it is. You can upload some scripts and execute it. So next what we did is create the bash script, upload it to the web server, and see if a reverse shell comes back. And sure, it comes back as user root, which is the administrator of the device. So game over for that one. Another interesting device we're going to look at will be presented by David again. Back to you.
Thank you very much, Dario. Yes, this was a second IoT device that I was able to analyze during my bachelor thesis, actually, which I did in cooperation with InfoGuard. And it's a smart solar controller. So how does your modern solar system look like? And of course, here at the top, you have the solar. How does this work? Perfect. Okay, you have the solar panels, and then maybe you even have a car charging station which charges your electric car, and at the bottom, maybe even a boiler which heats your water based off of that electricity. And here in the middle, this small red device that you can see, that's exactly the solar controller. Now, what does this device do? It essentially monitors how much electricity is produced by the solar panels, and depending on that, it turns on or off the other IoT devices connected with this system. So, for example, the car charging station. Now, because the owner of these solar panels, of course, wants to monitor his electricity production while he's sitting at the beach during his vacation, all of this is connected to the cloud. So the solar controller has its own cloud, and also the car charging station, for example, has its own cloud, and the solar controller can turn the car charging station on or off using the car charging station's cloud. Now, of course, as we know, IoT connectivity, putting something into the cloud, brings many features. It enhances user experience, but it brings many risks. So what could go wrong here? We looked at the solar controller cloud a bit more, and we saw that it basically consists of a web portal, which allows the user to configure the device, and an API, which exposes the device's configuration if needed. And when analyzing this API, we saw that it was actually available unauthenticated, so it was publicly readable by anyone on the internet, as you do, and it exposed all of the configurations of all possible controllers, of all existing controllers. Now, because these controllers also had to control, for example, the car charging station, they of course needed the credentials for those other IoT devices, and those credentials are of course also written inside of the configuration. So an attacker can basically, by reading these configurations, gain access to these third-party IoT devices connected to the solar controller. So through this cloud, we are able to control other devices. This is an example of such an API endpoint exposed. As you can see here, username and password are readable without any issues, meaning I can turn on or off your car charging station at home if you have this device hooked up to your solar panels. Now, the second component was the web portal, and we also analyzed this web portal. And it used a JSON web token for authentication. This can be imagined like a key. Each user has an individual key, and this key is signed by the server using a secret, a password for the signature. Now, this web portal, as a secret, used a publicly known password. It was probably left inside of the framework by the developers. The default value was not changed. And by figuring out this secret, this password, what can we do? We can sign the keys ourselves to make them seem legit. So we can create any key and put the signature on it to make it look valid. By that, we can impersonate basically any user account, including installer accounts, which have access to all of the devices. This is such an example as we did it. You can see here I am trying to get the user description, the description of my current user, and here we can see that my role is photovoltaic installer, so I have access to all of the devices. This means that not only can we control the car charging station, but through overwriting the configuration by impersonating such a user, we can also control all of the other connected devices with it, including, for example, your smart boiler. Now, we talked to the vendor and told him about these vulnerabilities, and he mentioned an even bigger risk to us because, of course, now we can control one household. We can control the car charging station, the boiler, but not only do we have control over one household, but over all of them. So what if we simultaneously would switch on or off all of the boilers here, for example, in Switzerland? If enough devices are hooked up, this could lead to a destabilization of the power grid due to the electricity fluctuation, causing maybe even a blackout if the scale is large enough. Furthermore, we can, for example, lower the boiler temperature in a household and thus disable the Legionella protection and create a health risk for all of the people inside of the household. So what do we see here once again? As always, IoT, connectivity, cloud, etc. brings many opportunities, but also many risks. And as we saw here, centralization massively increases the risk because the only vulnerable part was the cloud of the solar controller. But through this cloud, we were able to exploit and gain access to all of the other devices connected with it. All right. Now, having talked about IoT and physical attack paths, let's maybe move on to something a bit more standard, web applications. That's something we look at quite often, but also here we sometimes see one or the other specific case which is a bit interesting. So Dario, go ahead.
So we're also going to look at the case at the client once again. So that client ordered the external penetration test. He had an extremely small attack surface, so only 2 web applications were available. All of the IPs he gave us had no unnecessary ports open, and anything else we found, like information in the internet, was not useful. So I moved forward, looking at those web applications. One of those prompted that login screen on the right-hand side. It's a bought solution, so he bought that from a software provider, but we don't have credentials for that. What I like to do usually is start with looking at the static source code. This is the JavaScript loaded into the browser, which is then run on the client side. I see some smiling, someone already noticed. Here the code compares if the username is equal to administrator, and if that is the case, the role admin is assigned. So it's a bit weird. That's the code in the browser. Shouldn't the server know if someone's an administrator or not? So, well, let's just give it a try. Put in administrator as the username. Password, yeah, don't even bother. Just enter. Yeah, that's an administrator console. It looks more interesting than it was. It just had some licensing information, some information about the client, and some installed modules. So surely if so much things are handled on the client side, there must be more within the static code. So looking around, looking at comments, I saw there's a comment control space. I could read through and figure out what it actually does, or just press it. If you press it, there's some secret menu appears. It's always a good sign to have secret menus, because if you hide them, you're much more secure. I don't know what it does. Just put in test and look at the request. So it's stating off, something like authentication maybe, and the server gets back with fail. So what if you could intercept the response and change that to success? Let's use a man-in-the-middle proxy, Burp Suite, maybe you're familiar with that. You send an auth request to the web server through the proxy, and when the response comes with failed, you just stop at the proxy, change out from fail to success, and see what happens. We get the nice new interface. This time you can execute SQL queries, read out log files, and interestingly, read out configs. In the background, SQL, so there's an SQL database somewhere. In the config there is the password. It was so great, the password, that I can show it to you. It's surely a great sign of security when the SQL database password is SQL. The client wasn't happy, immediately called the manufacturer of the software, and that manufacturer replied quickly, said, yeah, we have an emergency update ready. We can give it to you. You will deploy it within 24 hours. So yeah, on the next day, I could start over again. So the secret interface with control space wasn't working anymore. So it must be fixed. What if we just use the URL of the log files? Yeah, we can still look at the log files if we know the URL. In there was a new interesting thing I didn't had time the last day. There was a SQL error. So I figured out, yeah, well, why don't I try to inject some SQL queries into the request and see if I get any response. So how that works, like usually your browser sends the name and the password to the web server. The web server sends that forward to the database, and then the database answers if yes, that's the right password to the user or not. What I've done, I've injected my own SQL query, which was then forwarded to the database and interpreted by it, and that one happily returned with all usernames and passwords getting back to me. So that's not great, having usernames and passwords, as you can imagine, but luckily this was a Microsoft SQL server, which has a handy feature called XPCMD shell. With that, you can execute code onto the server of the database. It was disabled, but our account we had before was the sysadmin of the database, so we can just re-enable it. And then I've, as an example, executed that ping command to a controlled server of mine, and surely enough, I got a hit back. The ping command reached our server. So the conclusion, the customer had done quite things right, had a small attack surface, even multi-factor authentication was enabled for the login screen, and our automatic scans and his vulnerability scans didn't find anything. A couple of days later, the perimeter is breached. Yeah, he didn't test the solutions and the softwares he bought, and that way we got in. Another thing he bought was an EDR. The EDR was triggered, isolated the server, and contained the attack, so I couldn't move forward from that perspective. But still, not a great point to be in. For the next application, I think we have some time.
We have 3 minutes, right?
I'm going to hand over back to...
5 minutes even, wow.
Back to David.
Thank you very much. Okay, so then I don't need to do a speed run. Good. All right. Well, thank you, Dario. This is the second web application, also an interesting case when I browsed to this website. First of all, two things I noticed. It looks like a Windows window inside of a website, which is strange. And second of all, we see here up in the corner, it's called dev test, so a developer test environment. Now, these environments usually tend to lack security because, of course, only the developer will access it, right? We can see here, this is an application later I found out, which hosts .NET binaries, so simple executable files meant for Windows as a website. And it has two buttons, Save File and Open File. Now, what happens when we press Save File? You might have guessed it, we can upload a file, and the application returns us the path where this file was put. And then the Open File button opens an Explorer window. We can browse to the application, execute it, and we have remote code execution. It wasn't that simple, sadly. So this Explorer environment was quite restricted, so you weren't able to execute this file. You couldn't even really copy it. But with some trying around, we noticed that, for example, if you hit send to, you can still move the file to different locations. So using some of these tricks, we thought about how could we exploit this. Now let's look at how this application is built on the inside. We have certain folders which host these applications. They're simply an executable file inside of it. So if we cannot execute our uploaded file directly, what if we can replace one of the existing applications with our own? So let's try that. I downloaded the software with which you can create these applications that you can host inside of a web application and created this simple form. The most interesting part here is the execute button. It basically runs this code, which just creates a text file inside of the documents folder to show that the code was indeed ran. Then I uploaded it. I removed the original application by renaming it with _backup. You can see here down a few more test versions, so it took a while to get it running. The timestamps also tell a story, so I really wanted to get this to work. And indeed, after replacing the original application, we can see it's hosted inside of the web application. And once we hit the execute button and open the file explorer we saw earlier, my output file magically appears. So we indeed have code execution here. Now I called the customer, told him about this critical vulnerability. 2 hours later, he comes back to me, calls me, David, it's fixed, please check again. So I open the web application and I just see this. So this is an error, the whole application crashed, it's down, it's not even reachable. And the conclusion by the customer was, well, if the application is not reachable, you can exploit it as well, right? So that's an interesting solution here. Now, all of these examples are a bit non-standard ways. We saw interesting web applications, we saw physical social engineering. So what is our conclusion here? Conclusion is that the perimeter is everywhere. It's not only the servers or web applications, but it's the sensors, it's the physical spaces, or maybe even the device you forget in the train, or the third-party apps that you assume to be safe. Furthermore, security is more than technology. It's about the processes and people that can maybe identify a breach or a physical intruder who tries to gain access to, for example, the server room. And finally, continuous testing is essential. Cybersecurity is an ever-evolving space and it's moving in a rapid speed. So it's important to stay up to date and maybe think about the non-standard ways, because attackers also need to get creative, and they do get creative when trying to reach a certain goal. They always find new attack paths, new methods to get, for example, inside of a network. That's why it's important to also go beyond the mainstream testing, and maybe next time someone is walking around in your office carrying a ladder, you do look twice. Thank you very much.
Thank you very much, Dario. David, that was really great. So I'm really sorry I didn't want to stop with great use cases. tips and case studies and insights. I fear the time is already up, but I'm sure you are welcome to have questions from your audience in the breaks. Please find the two. Thank you very much.
Thank you.